Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay back with another geometry video for you all. Today's lesson topic is all about coexistent and oblique triangles. This is a build-up off of our previous video that I made, which was all about the properties of rectangles and triangles, as I went into specifics about triangles, and I also went into specifics about the triangles in constructions with polygons, about the different types of polygons or their separations. But now we're going to try and implement a new topic and concept here in which you're going to actually create coexistent triangles, and we're also going to mention oblique triangles in relation to area with regular triangles as well. So these are some special type scenarios. So today's not going to be too long of a lesson. This is going to be a bit of like a special case scenario, some of these higher level thinking items and enrichment items that you guys should really look out for. But before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts at eCoreAcademy. All of those things are very greatly appreciated. Now, the concept and purpose of today's lesson is to discover what are some coexistent triangle pairs and what are some oblique triangles. So these are some special case scenarios of triangles in geometry. And triangles are basically like the building block polygon in all of geometry. It's the polygon with the least amount of sides. A lot of concepts are actually derived from the triangle, and believe it or not, they're probably most numerously come across topic-wise and relationship-wise in geometry. So let's jump right into it. Let's start off by looking at coexistent triangles. What exactly are coexistent triangles? And then we're going to later discover all the different possibilities and combinations with these coexistent triangles. So let's look at triangle cross classification. That's another way of calling this coexistent triangles. It's where you cross classify triangles with two different elements combined. So coexistent triangle pairs are types of classifications in which combine the identification of a triangle by its angles and sides. So if you refer to my previous video about constructions with polygons, I showed you how triangles can be identified by angle classification, meaning equilateral. Angle classification, which is obtuse, right, and acute angles, acute triangles. So those are the three types of triangle classifications by angles. And then the three side classifications are isosceles, equilateral, and scalene. But what we're basically doing here is we're just combining both of those, because any triangle is going to not only be cannot only be governed by one classification, meaning it cannot only be classified by angles, but if it's able to be classified by an angle, it can always be classified by sides. So a triangle is always going to be able to be classified by one kind of side classification and one kind of angle classification combined, and that's basically what we're going to be doing today. We're going to be identifying which combinations work and which ones do not exist. So if you look at a triangle here, if I were to identify its angles here, I'm going to draw these angles out. If I draw these angles out and I'm going to draw these sides out saying that they're all congruent, well, we're identifying by both its angles here, so we're going to account for angles, and then we're going to identify what kind of angle it is. So, what kind of angle classification this triangle is. Account for angle, so angle classification. So you're going to classify. And then you're going to account for sides. So you're going to account for these sides. Account for sides. And then you're going to classify. And all you're doing is literally just hyphenating these two. And these two are going to be combined together. So I'll just write that down here. Combine. That's all you're doing. Very simple. So let's look at some coexistent triangle pairs, part 1, and this is basically all the possible triangle classifications. So for this slide, I'm going to split this up into classification by angle and by side. So we're going to start off with all the possibilities all the possible side classifications that you can combine with an acute triangle. So these are the three first triangle classifications with all the types of side classifications that you combine with an acute triangle. So the first type is an acute equilateral triangle. So you can have an acute equilateral triangle, which is one solid triangle. You can have an acute scalene triangle, and you can also have an acute isosceles triangle. So an acute equilateral triangle is when a triangle has three equal sides, and it also has three acute angles. So that's always going to be true, because an equilateral triangle, I'll draw this out. So let's say that this is our equilateral triangle. I'll just draw this line here. and say, for example, this arc represents a acute angle. So if we look here, we have 3 acute angles here, and we also have 3 congruent sides by these tick marks here. And equilateral triangles will always have acute angles. So therefore, an equilateral triangle can only have an angle classification as acute. So it'll always have 3 acute angles, and they will all equal 60 degrees. So it'll always have 3 60-degree angles, and it will always have 3 equivalent sides. And then for your acute scalene triangles, you can have an acute triangle with no equivalent sides. So let's just draw this out, for example. So let's make these meet here. So let's say that none of these are equivalent. So we're going to indicate this by separate tick marks, and we're going to show that this has, 3 acute angles. So this is a scalene acute triangle, and it is proven to be true because you can have, when it's a scalene triangle, you can have 3 different types of measures, which are 3 different acute angles, which falls under the law of an acute triangle. And then finally, we have our acute isosceles triangle, which is a triangle with 2 equivalent sides and acute angles. So that's this one right here. So I'll draw this out. So let's use let's use this example right here. So if we assume that it has 3 acute angles, and we assume that these 2 sides are equivalent and this side is not, that means it has 2 equivalent sides in a scalene triangle, isosceles triangle, and it has 3 acute angles. And in an isosceles triangle, you're always going to have 2 angles that are equivalent and 1 angle that is not equivalent, just like the side length. So you can always have two acute angles of the same length with any other angle added on. That can still be an acute angle, so that is also a check. So I'm going to check these off, saying that all of these work. Now let's move on to our coexistent triangle pairs part 2. And now we're going to see all the possible combinations for side lengths that you can put with a right triangle that's given. So all triangle classification continued, and this is specifically for a right triangle. So you can have a right scalene triangle and a right isosceles triangle. Notice how I didn't put an equilateral. That's because you cannot have an equilateral triangle that's also a right triangle. An equilateral triangle will always be an acute triangle, and it cannot be obtuse or right. That is due to the fact that an equilateral triangle will always have angles that are 60 degrees, which is by definition acute. So it cannot fall under right or obtuse triangles. However, a right triangle can always be a scalene triangle, meaning no sides that are equivalent, and it can also be an isosceles triangle. So we'll draw those out. So a right scalene triangle will look something like this. So no sides are equivalent. You can have something like this here. And you can state that, well, let me erase that bit off. Let's redraw that real quick. So you see here, we'll indicate that this side is one length, this side is another length, and the third side is its own length. But you can always have a right angle here and 2 acute angles. Therefore, this can always be a scalene triangle. And same thing for an isosceles triangle. Draw this out here. Draw a right triangle here. The cool thing about an isosceles triangle is that only 2 legs. We already know what 2 legs have to be equivalent in an isosceles triangle. That is the height here and the base. So the base and the height always are going to be equivalent. A hypotenuse cannot be equivalent to those 2 measures, or it cannot be its own equivalent to any other one of these side lengths, because it's going to be the largest and longest length in the right triangle. So it's going to be its own length here, the hypotenuse. And of course, you can have a right angle and 2 acute angles as well. And finally, let's move on to coexistent triangle pairs part 3. And that's going to be, we're going to continue with triangle classifications, and this is going to be specifically for obtuse triangles. So we're going to see what kind of side length classifications for triangles can be combined with obtuse triangles. So the 2 types are going to be scalene and isosceles, so obtuse scalene triangles and obtuse isosceles triangles. Remember, equilateral triangles are always going to be acute triangles, so you cannot have obtuse or right triangles being combined with them. But you can have obtuse scalene, and you can also have obtuse isosceles. So notice how I say that for your obtuse scalene triangles, I'll tell you later for isosceles, but just like the right triangle, you can always have 2 equal you can always have two equivalent angles for a right scalene for a right isosceles triangle, because you can have a 90, 45, 45 degree triangle, because after you have a 90-degree angle, you have 90 degrees left in that triangle, and therefore 90 divided by 2 will always be 45. So that's how you notice that that'll always be 45. And then for obtuse, that's for any scenario. It does not have to be a specific amount, but it can be specified later on. But for scalene triangle, it's very simple. You can have completely different sides. So I'll draw a scalene triangle here. I'll make this an obtuse angle, make that an obtuse angle, and make these two acute angles. And we can just indicate here. Sorry about that. Let's just redraw this real quick. So I'll draw out an obtuse triangle. So we'll start off with our identification through angle. So once I've drawn that, we can tell that this is obtuse, and these two are smaller acute angles, and these are all of different all of different measures. And finally, we have our obtuse isosceles, and that'll look something like this. Sorry about that. Let's just erase this real quick. Had a little malfunctioning on my writing pad. So we'll draw this out here. And we'll say that these two are congruent sides. This is an obtuse angle. These are two acute angles. So we can just prove this here, and this is a separate side length that is not of congruency with these two other sides. So we can prove that. So yes, these are all possible classifications, so I'd recommend that you write those down. Go back in the video if you don't already have them. They're going to be really important coming later on. They might, be thrown at you, maybe a bonus question on any quiz that you're taking at school. So really take this into account. These are some special extensions. Remember, we are an Enrichment Academy, so we're actually built for this stuff. We're trying to get you, shine some light, put some perspective on these items, because they might actually come into very useful necessities. When kids are stumbling on the same problem as you already know after looking at this video, you can thank us later. So let's move on to oblique triangles now, the second half of our lesson. So what are oblique triangles? Oblique triangles an oblique triangle is an oblique triangle is considered oblique triangles. An oblique triangle is considered an improper triangle, as it is any triangle that does not have a right angle. So a proper triangle is basically a right triangle. Any other triangle, which is acute or obtuse, is always going to, or even equilateral, is going to be an oblique triangle. And the area formula will still apply for all types of triangles. And remember, for whenever you're doing the area formula for a triangle, you're always going to start off with the right triangle, because the height of the triangle is given as a side length. But in an oblique triangle, since they're not right triangles, these side length, they don't have any heights that are given as side length, meaning the altitude has to be calculated differently. And the altitude is another way of saying the height. So the area formula will still apply for all types of triangles. However, you need an extra dimension, which is the altitude of a triangle, and that's always going to be necessary in order to calculate the area formula. You don't necessarily need that in all cases. You can calculate it on your own, but in this time, since we haven't gotten to those higher complex trigonometric functions, we're just going to merely look at problems that are already going to give us the height of oblique triangles. And like I said, oblique triangles do not have the side length, which is a height of their triangle. So, but the area formula will apply to all types of triangles. So let's look at altitude. So altitude is that one measure that you need for oblique triangles in order to calculate the area of a triangle, of an oblique triangle. So you're going to use altitude to calculate area. Altitude is a measure of the height of the triangle. Right triangle has a side length that measures its height already, but an altitude is an extra line that basically connects the top of the triangle. So what it does, the altitude of any oblique triangle is a line that is perpendicular to the base of a triangle. I'll draw that out here. So if you have, say for example, an oblique triangle, it looks like this, and we know that this is the base. Then the line that intersects this base at a 90-degree angle will be the height of the triangle. So that'll be the altitude. So height equals altitude. All right, let's look at some special case scenarios here. So in an obtuse triangle, the altitude will be on the outside of the triangle, meaning it will not be on the interior, it'll be on the exterior of the triangle. On a right triangle, the altitude is on the triangle, it's one of the side lengths of the triangle, the altitude. And then the acute triangle is basically, in an acute triangle, is when the altitude is on the inside of the triangle, so it's going to be on the interior, just like this example right here. All right, let's move on to two problems. I'm going to do one for coexistence and one for oblique triangles and calculating the area for them. So this is an example of oblique triangles here. One is on the inside and one is on the outside. I'll erase this and clear this up for you. Just wanted to write that out, give you an example. So on an acute triangle, you'll have the altitude h, which can also be represented by A or H, will be on the inside of the triangle. On an obtuse triangle, the altitude or height will be on the exterior of the triangle, and it basically intersects the base that is extended outwards on the exterior of the triangle at a 90-degree angle. And then finally, you have your right triangle, which is basically this line segment here as the height, and as it also intersects the base at a 90-degree angle. Now let's move on to our problems. One for coexistence or identification, and one for oblique triangles, calculating the area. So let's look at coexistent triangles, our practice problem. So identify what types of triangles these figures are. So we have two triangles here, and all we're going to be doing is we're going to use coexistence to coexistent triangles to calculate what kind of identification these two triangles are. So this triangle here, as you can see, it has three congruent sides. And it has three congruent angles, and we know that equilateral triangle, it's an equilateral triangle because it has all congruent sides, and we see that 60, 60, and 60, they're all less than 90, so they're all acute angles, and we already know that equilateral triangles are always going to be acute angles, so we can tell that this is an equilateral acute. And the thing about equilateral triangles, you don't necessarily need to identify it as acute. You can just identify it as equilateral because it's already assumed that it's going to be acute. So equilateral, you can just identify it as equilateral. And then for this triangle right here, we already see that it has a right angle here, so that means it must be a right triangle. And as you can see, in a scalene triangle, since we don't have given side lengths that are congruent, we do know that in isosceles triangles, you will have two congruent angles that will be given. So we have one 90-degree angle here, and as you can see, we have two congruent angles, 45 and 45. That makes this triangle here a right isosceles triangle and not a right scalene, because we cannot have a right acute because that's not possible. So it's going to be a right isosceles. And I'll just write triangle here. Alrighty then, let's move on to our final problem, which is oblique triangles area practice, and we're just going to be calculating the area of this oblique triangle right here given. So this is obviously an oblique triangle because it does not have a 90-degree angle at any of its vertices. But we are given the needed dimensions, which is the base 9.8 and the height 3.6. So we know that the area formula for a triangle is area, which is represented by A equals base times height, which is also known as the altitude, so I'll write that here, also known as altitude. And that's going to be divided by 2. Everything's divided by 2. So that's base times height over 2, or base times altitude divided by 2. So we're going to look at our information here. We know that our height or altitude is equivalent to 3.6 centimeters. And we know that our base is equivalent to 9.8 centimeters. Now we're going to multiply 3.6 and 9.8. So when we multiply that out, you can use long multiplication or multiplication process. I try to keep my work in one corner and keep my listing in another corner. So you should probably pick that up as well. It keeps you very organized. We'll do it over here in this corner right here. 3.6 times 9.8. And just go ahead and calculate that. 4, 8. 0. Any way that you want. If you're not used to this process, the formal process, you can do it in your own form. 1, 2, 8. Oops, sorry about that. 2, 1. And so the area equals, so we did 3.6 times 9.8, and that's 35.28. And now we're just going to divide that by 2. And we get that 35.28 divided by 2. You can look at this, the properties of this. You can tell that 17 plus 17, 17.5 plus 17.5 equals 35. And you can add 17.5 plus 0.14 to get 17. So 17.5 plus 0.14 is 17.64. So that's 17.64 centimeters squared, and that's the area of this oblique triangle. Make sure that you keep all units of measure consistent as centimeters. And finally, as your answer, since we're calculating area, this will be units squared, so it's centimeters squared. All right, guys, I hope you guys enjoyed this video. This has been the eCoreAcademy e-learning platform today. Please make sure to like and subscribe down below. Hit the notification bell to get notified on any of our latest posts. Even visit our website at www.ecoreacademy.org. We have that link in the description below as well. We have full unlocked access to all of our integrated note sheets, quizzes, and worksheets that go along with each and every video, organized into course studies with other tips and tricks and added perks that that go beyond all of our social media platforms and, of course, our YouTube channel. So please go ahead and check that out. It's completely free, and all you have to do is make an account. Email us at eCoreAcademy@gmail.com if you have any questions. All of our contacts and our address information, if you need to mail something to us, is all at our website if you want to visit it there. But our general email is at eCoreAcademy@gmail.com if you want to ask us any questions or, just reach out. And finally, you can visit all of our socials, and they're in the description box below. Their links are down below. That's Facebook, Twitter, and Instagram. So check a follow for us down out at any of those platforms. And also see what kind of content we have there, see what kind of unique content we have, and share all of our videos through those mediums. Once again, you all, I hope you guys enjoyed, and this has been AJ, and I will see you guys in the next one. Peace.